Hello and welcome to our heat transfer lesson. I am Zakum Gansi and I'm here with my colleagues Umari, Shongwe, Nolutando, Kumalo. Thank you. Alright, so what we will do, we are going to explain heat transfer energy using 3 different stages: conduction, convection, and radiation.
These are the list of materials we'll be using. We will be using Drinko pop, matches, tin cans, bottle cans, candle, and a metal spoon.
Alright, so now we will be demonstrating conduction. Right here we have the tin can, we have a box just to put it so it does not get messy, a candle, and a lighter, but students please be cautious of these things. And we have a metal teaspoon. Right, so with this tin, we will pour some hot water. Right, okay. And we will then place the metal spoon inside the tin can. What exactly does this metal spoon do? Ouch! This shows that metals are good conductors of heat. Hence why this whole process shows conduction.
So now we're going to show convection. So we'll take our cold water, pour it into our plastic cup. Then after we take our food coloring, pour it into our cold water. Then after that, we're gonna pour our hot water. So now watch as the water, as our colored water moves around our cold water. Not sure if you can see the steam. Yes. So the warm water rises and the cold water sinks. That's what we call convection.
I am about to explain to you guys the process of radiation. So in my can I have water. Please light the candle. If I put the candle beneath the water, I am applying heat. As you can see, there is steam coming out on top, which means that the water is getting heated. This would mean that the heat energy from this candle is being transferred through the can, heating up the water. And that is the process of radiation in simple terms.
So we will explain the purpose of a shoestring resource. Okay, let's start by defining what a shoestring resource is. This resource is designed to help learners explore and understand concepts. In our case, it will be heat transfer. Even when there is limited funds, materials, or equipment. So, especially in more disadvantaged schools, shoestring resources can be used. Alright, it helps students engage actively in hands-on learning by using whatever materials they have available, especially with recycled materials. Alright, rather than relying on things that are expensive, like going to buy a whole thermometer, when you can use, for example, I don't know, like a metal spoon. Okay, so, for example, according to the NSTA, National Science Teaching Association, it says that science isn't just about how much stuff students use, but rather how they think using whatever is possible. For example, all of these materials will be used to make a heat transfer shoestring resource.
It promotes creativity and resourcefulness because you have to make something work with simple or recycled items. For an example, we had to use whatever we could find to make this work. You think more about design, how heat moves, what materials will show that, etc. For instance, an article in India Bioscience about biology practicals say that students and teachers can build effective experiments on a shoestring budget even without full laboratories. It makes science more accessible regardless of the budget. If expensive lab gear isn't available, but you can still show conduction, convection, and radiation with cans, foils, bottle, etc., the materials that we have used, then learning still happens.